activity I gave you in the previous lecture. We will add a new service server inside the number counter node that you created in the last section. So here is the code for the Python node. I will provide the video solution for Python, and of course you can also find the C++ solution inside the code archive that you can download at the end of the section. So quick recap about this node. We have two communication features, one publisher and one subscriber. So the subscriber will listen to the number topic. When it gets a message, it will go to this callback, and in this callback we will increase the counter that we set as 0 here. We'll increase the counter with whatever data, whatever integer we received from the number topic. And then we publish the new value for the counter every time through the number count topic. And what we want to do here is quite simple, is that we can ask from the outside of the node to simply reset the counter to 0 at any time. So the best solution here with Ros2 is to actually create a Ros2 service, because this is a quick action to do with a kind of a client-server architecture, and services are best suited for that. Also, I gave you the interface you need to use, which is the set bool service, but I didn't give you the details about that interface, so you can find them with Ros2 interface, show example interfaces, srv and set bool. Great, we have some commented lines, and we can see that we have one field for the request and two fields for the response. The request contains only one boolean, so bool here is another primitive data type for Ros2 messages and services, and the name is data. The request contains a boolean named success and a string named message, so you will be able to send a success flag along with a message to explain what happened. And what we will decide to do, and this logic is just specific to the application we are doing, is to say that if the boolean is true here, we will reset the counter, and if it is false, we will not reset the counter. So now the first thing we need to do is to include actually the set bool. So from example interfaces.srv, okay, messages here and services here, import set bool. Okay, we have our interface here, and we can create a service server. Let's put it just after the number subscriber. So self, how to give the name to the variable? Well, let's keep things simple and meaningful. We want to reset the counter, so reset counter service. That's it. And we will use self create service. Okay, to create service directly from the node. We need to give 3 arguments. The first one is the type, so we already have it, set bool. Second one is the service name. And here, as I told you, it's important to give a meaningful name and preferably a verb. So the verb will be reset counter. Okay, we reset counter, it's quite descriptive. And finally, we need to give a callback. Okay, so when we spin, when the node spins, the callback will be called when the server receives a request, so we can process the request and send back the response. Let's create a new callback function, callback on reset counter. Inside the callback, we will have the request and the response. And as you can see here, I used callback number as the subscriber callback for number topic, and callback reset counter for the callback for this service here. Okay, so we add self callback reset counter here. Let's do some formatting, and now we can write the callback. So what we will do is we will check if response.data. Okay, the boolean is named data. So if the boolean is true, then we reset the counter. Self counter becomes 0 again. Okay, every time we receive true as a request, we will put the counter to 0. And we also now need to fill the response with something. So response.success and .message. Response.success, let's say true, and response.message will be counter has been reset. So it's a confirmation that it worked, and else. So if the response data boolean is false, we will not reset the counter, and we will consider that the success is false. So response success. So that does not mean that the service call failed. Okay, if you receive a response with that success flag, it means that the Ros2 service worked correctly, and what we consider as a result which is not a success is at the application level, okay, not the communication level. Response message will be counter has not been reset. So for example, if you need to activate some hardware component, and if you can't activate it because you have some errors, and if you want to have a message in the response, you can maybe provide why this failed, okay? And the last thing you should not forget is to return the response, like that. Okay, very important, don't forget to return the response. And I just realized I made one mistake here. Instead of using the request, I used response. So if you try, of course, to access the data field in the response, well, it doesn't exist, so you will get an error here. So now it's correct. And let's compile Ros2, let's build and install the node with colcon build packages select and my Python package. Okay, so in that terminal, I will start Ros2 run my Python package with the number counter that we just modified. In that terminal, I will listen. So let's check Ros2 topic list. So I will listen to the Ros2 topic echo number count. As you can see for now, it's empty. There is no message because the number counter only publishes when it receives a number. So we will also start the Ros2 run my Python package number publisher. Okay, we start to publish from there. The number counter receives the data and it can publish on the number count topic, which is what we already got for now. And now, if I check Ros2 service list, we have here reset counter. So the service is here, Ros2 service info type. You don't have Ros2 service info. Reset counter will give you the type you need to use. Okay, great. And now let's call this Ros2 service call reset counter with the type, and we need to send one data field, and let's start with false. So with false, what will happen is that, as you can see, the counter will not be reset. So we sent the request, the server here processed the request, and we have the response success false, message counter has not been reset. So the communication worked great, okay, everything worked great, and just because we decided at the application level to say that the success was false, then we get this response. And now let's do the same but with true, and let's look at the counter here. The counter has been reset, great, you can see it's going back to 0 and then to 4, 6, etc. And we get the response here, success true, counter has been reset, and you can do that at any time and it will always reset the counter. Great, so the activity is now finished. Here we use a Ros2 service call from the terminal. You can also use R2T, the R2T service plugin, and if you want, you can also try to write a client, a Python client or a C++ client to call this service. It's basically, well, it will basically follow the same structure as this or this one. What is a Ros2 interface? In the previous sections on topics and services, you have used some common interfaces to communicate between nodes. With topics, you have seen that all nodes publishing or subscribing to a topic must use the same data type. With services, you have seen that the client must send a message respecting a certain data type, and the server must respond with another message respecting another data type. A topic is defined by two things: a name, so you can recognize it, and an interface based on a message definition, which is the data structure of the information you send. A service is also defined by two things: a name, so you can recognize it, and an interface or service definition. The service definition contains one message definition for the request and one message definition for the response. Well, you can see topics and services as the communication layer tools, and interfaces or messages as the actual content you send. Let's just make another very simple real-life analogy. When you send a mail, the transport company will carry your letter. The content of the letter is the analogy of a Ros2 interface, here using, for example, a message definition. When you send a letter and you wait for a response, then the first letter contains a request message, and the letter that you receive back contains a response message. The combination of the two message definitions is the service definition. Alright, as you can see, message and service definitions are quite useful. Without them, you would have nothing to send over a topic or a service. So now, technically speaking, how is it possible that you can use those interfaces directly in your code? Because for now, it just looks like a bunch of simple text. Well, let's say you create a message definition here inside a package. When you use the call.build command line, the message will be passed by the build system, and then a source code will be generated for this message in any Ros2 supported language, C++, Python, etc. Your interface is now ready. So that's why you can, for example, directly include the message header in your C++ code, because the build system generated this header file. And now, what kind of data types can you use to create a message or service definition? If you go on the Ros2 interfaces page on the ROS index website, you can find all the primitive data types that you can use. Among them, you can see, for example, boolean, float number, integer numbers, strings, and you can also use arrays of primitive data types. As you saw in previous sections, we already used some of them, for example, the int64, the string, and the boolean. And with one data type here, you have the corresponding data type in C++ and Python. So for example, the string here will be a std string in C++ and a built-in string in Python. So now we're going to see the example interfaces package that you can find on GitHub under the Ros2 organization page. So we've already used a few of those messages and service definitions. So you can see here we have an MSG folder and SRV folder. So let's check what we have inside MSG. And you can recognize here, well, where it is here, int64.msg. So if you click on that, you have the message definition that you already saw in the terminal. And as you can see here, we used an int64, which is this primitive data type. Okay, we can also see on the services, we have three services. The set bool, for example, we have exactly what we used in the section on services. So one bool data type here, it is a primitive one, another bool, and a string. Well, the example interfaces are just examples, okay, as the name suggests. And we will check actually a few other messages and services that you can really use in your code for real applications, and you can find them in common interfaces. So you can go to this page here, common interfaces in the Ros2 project, and you can actually see a lot of folders, and those are actually packages. So this is like a meta package which contains many other packages. So some of them may actually be installed when you install Ros2 with the Ros2 desktop installation. If something is missing, for example, if geometry messages is missing, you can simply install that package with ros-name of the distribution, so for example Foxy. So you will have ros-foxy-geometry-msgs, and then you can install the package with apt install. So let's check a few of the messages so you can see what you can actually build with messages. Let's go into sensor messages. And here you can see we have an MSG folder and also an SRE folder, so we both have messages and services for this package. If we go to message, we will actually see the joint state message. You can see we have many messages again here. If you go to joint state message, that one will be quite useful when you work with your robot. It will allow you to send position, velocity, and effort for each joint of your robot. You can see here we have a lot of commands which will not be passed, and we have first the header. The header here comes from another package. So when you have something like that, the first thing is the name of the package, then slash, and then the name of the message. And it has an uppercase here, so it means it's not a primitive data type. It is another message that you can include, and you can find the definition of this message in this package. And now we have an array of string, an array of float for the position, another array for velocity, and another one for effort. Okay, let's check another interface, another message in geometry messages. So here we don't have a SRE folder, okay, it's only messages for this package. And let's check the twist here. The twist is used by TurtleSim to actually send a command, the velocity command, in the command velocity topic for the turtle. And you can see here we have two fields, which is linear and angular velocity. And actually those fields are vector 3. And this is not a primitive data type, okay? This is an already existing message. And if you don't see the name of the package in front of that message, it's simply because this message is from this package actually. So we just go back to the message folder of the same package and you can find the vector 3 right here. And the vector 3 actually contains 3 primitive data types. So we've seen some messages. Now let's see what we can get with services. Let's go back to the sensor messages and in SRV. For example, we have setCameraInfo.srv. Let's see what we have here. And okay, as you can see, we have the 3 dashes here. You always have that for any SRV file. Okay, so the first thing is the request, and then you have the response. And here you can see the request is actually another message. So you will have to find the message camera info from the sensor messages. So this is from the same package actually. You will have to find that message to see what you need to give as a request. So note that you can use other messages in services, but you can't include a service in a service. Okay, you can only include messages in a service. And finally, let's check the last one just to show you that you can really put a lot of things in a message definition. Let's go into sensor messages again. And we have camera info, okay, so that can be used for sending camera information. And so we have many commands, but as you can see, the message definition is already huge, okay? And we have unsigned integer here, which are primitive data types. Here we have another type, which is another message, and we have an array of float, another array of float here and here and here, a string, etc., and a header. Okay, so you can see you can put anything you want in a message definition, and in this lecture you will learn how to create your own custom message and service definitions. In your future Ros2 applications, you will then be able to use the custom messages you have created and also all the existing messages you see here, and you can also find many other packages built by the community on GitHub. So to create your own custom interfaces, you can use existing data types, and you can also reuse other message definitions that you've created or that already exist in a different package. In this lecture, you will see how to create your first custom Ros2 message. But first of all, where will you write the message definition? In which package? For now we have 2 packages. Well, basically you can technically add message definitions in any package you want. However, it will be much easier for you to create all the custom message definitions in a single package dedicated only to your custom interfaces. As you could see in the previous lecture with common packages like sensor messages or geometry messages, those packages are only dealing with messages and you have no code inside those packages. So with a dedicated package for interfaces, when you need to import a custom interface in another package, for example in one of those ones here, you will just need to add a dependency to this new package, and that's it. That will prevent you from having a dependency mess in the future. So let's create a new package in our source directory in the Ros2 workspace. So if you remember, we use Ros2 pkg create, and then we have the name of the package. And one convention that you can use is to name your package my robot interfaces. So of course my robot will change with the name of your robot, and then you have interfaces. Just like you had example interfaces, then you will write my robot interfaces. We don't specify a build type here, and we will not add any dependency because we don't need RCL CDP and we don't need RCL PI because there will be no code in that package. So we create the package, and if you go inside my robot interfaces, we will remove the include and source folder. So basically, if you don't specify a build type, it will still use one of the build types that are available, and by default, this will be a C++ package, okay? But we can just remove the include and remove the source folder. And instead, we will create a MSG folder here, okay? So let's see our package in VS Code. We have a symmetrics.txt, a package.xml, and a MSG folder for our messages. And before we can actually create and build our first message, we will need to do a bit of configuration, okay? So we will configure this package with those 2 files here, and once this is done, well, the package will be configured for life. So if you go to the package.xml first, you can see, okay, like I told you, the build tool dependent here is amon cmate, so build type is mconfig, which makes it a C++ package, but actually it's just a package, and we removed anything that has to do with C++. You can see here again those tags that you need to fill if you want to release the interface package, and we will need to add 3 new depend lines. So here it's really nothing you can find on your own. You just have to know, you have to write those lines, okay? So the first line you will write build depend with Ros2 default generators. Build depend. So that Ros2 will be the functionality to build and use your interfaces. Then you have a second line, which is exec depend, and that will be Ros2 default runtime. Exec depend. Okay, and a third line, which will be member of group, and that will be Ros2 interface packages with member of group. So well, just follow what I wrote here. There is really nothing to understand here. You just need to put those 3 lines inside the package.xml so you can import the correct generators and stuff to build and use your messages. So once you've done that, we are done with the package.xml. And we will need to also add 1 line in the cmeclist.txt. We will actually take that Ros2 default generators, and we will go to cmeclist.txt. And well, actually, that's like I did previously. Let's remove that and that make it more minimal. And you will add find package with Ros2 default generators required. All right, and so you have those 3 lines here you need to add, and this line here. And now your package will be ready to build your messages. So let's create our first message in the MSG folder. So I will go inside the MSG folder. And for this example, we will create a hardware status message. So let's say you have a package which will handle hardware driver for your robot. And from that package, you want to send some information about the motors, temperature, etc. So other nodes in your graph can get that information and know what's happening from the hardware. So we will create a new file, let's say hardware status.msg. Okay, and for the name of messages, it's important to start with an uppercase, okay, and always use uppercases for new words, okay? Don't use dashes or underscores, all right? And also don't name your message, for example, don't name the message here hardware status message.msg, okay? It's already a message, so just put the name like that with an uppercase and no msg inside the name. So it is here. So here, for example, we want first to get the temperature of a sensor in the robot, let's say int64 temperature, we will send an integer, okay? Then we want to know if the motors are ready to be used, and that will be a boolean, are motors ready. And let's say we want to add a debug message, string debug message. So here I just used some of the primitive data types, okay, and you save the file, so you have 3 fields in your message. So now we can come back to the cmeclist.txt because for now it's just the text, okay, it's just a text file, and we can't import the text file in our Python or C++ nodes, it will not work like that, so we need to generate source code, and for that you will add a new command here, Ros2 generate interfaces. So you will need to specify the package name, which will be project name, okay, and go here, and now you can put the message file here. So you will do that msg because it is in the msg folder, and hardware status.msg, and you save the file. So let's actually compile our package Ros2 colcon build. So let's use packages select. So we don't build all the packages we have for now with my robot interfaces. Okay, so as you can see, sometimes it can be quite long here, more than 30 seconds for me. But if actually I build it the second time, it should be much faster, okay? And if, as you can see, if you have many packages and you don't use packages select, then every time your build will be so long. So the messages have been built and installed, and let's check where actually they are installed in your workspace. So if you go to the install folder, you have here, you have a folder for each of your package, and let's go in my robot interfaces. We have, so let's go in the lib folder, Python 3, site package, my robot interfaces, and MSG. So it's quite deep, but actually the Python file is right here. Let's see what we got. Hardware status.py. Okay, as you can see, it's a complete file that was generated. Okay, you don't need to actually understand what it does, because anyway, you will just use it in your code by importing the message, and you will just use it like you use the example interfaces. And you can see right here we have the 3 fields that we requested. So that is the Python file, and if we go back to this folder, we go in the include my robot interfaces message, and you have the HPP file here. So again, what we got here, HPP, and well, okay, you have, in fact, you have many different files, and this will include all the different files. So if you go to detail, you can see we have many files. So in fact, it's just to show you that the files are here, but you don't need to worry about that. If you check hardware status, HPP, you have structure here, and you can see we have temperature, motors ready, and debug message, and you have a complete C++ file. Okay, so well, all the messages that you build will be installed right here. Now, and because we are creating new interfaces and new package, you will actually, if you want to see that, you will have to source your bash RC to source the workspace here, and you can do Ros2 interface. Show my robot, you can press tab, interfaces, and you have only one, so you have this, and you can press enter, and you have your message definition, which is right here on the terminal. So right, you have created your first Ros2 custom interface, and which is a message interface for now, and so that's quite a bit of setup. But now if you want to add a new message, you simply need to add a new file here, in that message folder, and then you don't need to worry about package.xml, and you just need to add a new line here. That's all. You don't need to do any other configuration. It's already done. So you add a new file here and a new line here. You compile your package, you source your workspace, and that's it. You can use your message. Let's now see how to actually use the custom message that you've just created inside your own code. So I will first do it in Python. So we create a new Python node. So let's go inside my Python package to create a new file. And so we have created a hardware status message. Here I will simply create a hardware status publisher, so we can publish this message on a topic. Hardware status publisher.py. Let's make it executable. Okay, and we can now edit the file. So let's use the template as always, and rename it hardware status publisher node. Hardware status publisher. Okay, and our code structure is now ready. So we will create a publisher here, and of course for this publisher we need to specify the message type. So we will first add the message type here, and okay, let's check the number publisher here. To import a message from example interfaces, we just use example interfaces.msg and then import the message, and so that will be exactly the same here, but we will use for my robot interfaces.msg import hardware status. Okay, that's it. And now, if you use VS Code, you may have an error when you import here. It may be right here saying it doesn't find the file. So this is just a tip for VS Code. Okay. In that case, you may need to add the include path for the Python directory where the messages are installed. So you can simply go to preferences settings. Then you can type Python path, and here you have Python autocomplete extra path. You can edit in JSON, and you will be able here to add one path. And if we go to terminal, okay, if you go to the install folder of your workspace, in my robot interfaces, you will go to the Python path for the messages, which is right here, this one. Okay, here you have the init.py for the messages, so you will simply add this to your extra path. Okay, you can save that, and that's it for VS Code. It should work now if it doesn't work yet. So you have my robot interfaces, and that is a new package we are using from that package. Okay, so we need to add a dependency in the package.xml, of course, depend. Okay, so we already have a dependency for RCApply and example interfaces. We add a new dependency for my robot interfaces, which means that when my Python package will be built, it will first check that my robot interfaces is here. Okay, so if my robot interfaces is not built yet, then this one will wait until this is built so it can build other messages here. And well, that's it for the setup for the Python package. You just have one depend line to add here, so you can use the package and then you import the message here. Now we will create a publisher, hardware status publisher. Self-create publisher with the type, which is hardware status, the name, which will also be hardware status, which is quite descriptive, and a queue size of 10. And now we will also use a timer, so we can publish on the topic at a given rate. And we will first create a function to publish the hardware status, publish hardware status. Okay, so we will create a message. So you can just do that, create a hardware status message. So as you can see, even if it's your own custom message, it's just the same as using any other messages that you've already used before. And inside this message, we now have 3 fields. Temperature, so let's say it is 45. Message, are motors ready? Let's say it's true. And message, we have debug message, which will be nothing special here. So you can fill any field you have on your message, and finally using the publisher, hardware status publisher, to publish your message. Okay, and now let's create a timer, self timer, which will be create timer. So we want to publish every 1 second, and we will actually put the publish function, publish hardware status. Let's put a log here, self get logger info. So I'm going quite quickly here because it's something that you already saw before. Hardware status publisher has been started. Okay, and the node is finished. So if you check the number publisher node, well, it is exactly the same code. Okay, we are just using a different message and different data here, but the structure is exactly the same. Okay, even if it's a different message. So let's now install this file in setup.py. We will add here hardware status publisher. Okay, let's use this simplified name here. So my Python package hardware status publisher name. Okay, we can now go back here and we can build welcome build packages select with my Python package and simulate install. Okay, I will source the bash sc here, and now for us to run my Python package hardware status publisher, and it is running. Okay, so here we can see Ros2 node list. We can see our node Ros2 topic list, hardware status. If I do Ros2 topic info on hardware status, you can see the type is my robot interfaces message hardware status. And now let's check Ros2 topic echo hardware status, and here you will get an error. Okay, why is that? Why do we get an error? Because we haven't sourced this session here, this terminal. So we still have the source for the global Ros2 installation and the Ros2 workspace, but before we actually built the messages and before we built the node here. So this terminal doesn't know the my robot interfaces package, okay, because we haven't sourced the session yet. Okay, so that's the kind of error you can get. Usually, when you get an error, always source your bash chassis, because maybe that was the problem. So now we can listen and it will work. And well, we just have messages that are printed. So now you're able to create your own custom messages and use them in your Python code. You can create your own custom message and you can use it in your Python code. And let's see, what about C++? So let's go see our C++ package. Here I have already written the file, okay, because it's very similar to what we did before. So I've created a hardware status publisher.cpp, which will do the exact same thing as the Python one. And well, this is just a typical publisher node. You create a publisher here with a type, name, hardware status. Then we have a wall timer to call this function at what else here. And so in this function, we create the message and we publish the message. So you can see we first include here my robot interfaces message hardware status.hpp. If you have any problem with this line using VS Code, okay, this is specific to VS Code, you can go here again in your C and CPP properties that we've already set before, and you can include that line. And that line is the install folder of the robot interfaces. So once you have built this package, then you have the include folder here that you can include in your project, so you don't have any include problem in your editor. So we already had that for Python here in settings.json, and you have C and CPP properties for C++. Okay, and that's it for the tip on VS Code. So you include that, which means that if you include a new package, okay, this is my C++ package, you also need to put it in the package.xml. All right, and as this is C++, you also need to add a dependency here, find package, my robot interfaces with require. Okay, so don't forget to add this line over there. Now in the code, well, you simply use the message as you did with the example interfaces package. Here we create the hardware status message and we can fill some data. I have used different data from the Python node, and then you can publish the message. There is nothing special if you already know how to create a publisher and how to use a message in your code. Well, that's the same thing. So now you can compile the code. Let's do colcon build packages select with my. Okay, so here I only compiled my C++ package, but make sure that you already compiled my robot interfaces before. You can also add it here, my robot interfaces. So we will build those two packages here. And as you can see, my robot interfaces will be built first because that package in the package.xml, we say that we require that one first. Okay, so that one will be built first. And now, well, you can simply source your bash RC and Ros2 run my CPP hardware status publisher and publish here. Let's make sure we have sourced the bash RC and let's echo what we got here. Okay, and in this terminal, let's start the Python publisher, Ros2 run my Python package with hardware status. Okay, and you can see that here, this subscriber on this terminal receives the data from both the C++ and the Python node with your custom message. In this lecture, I will show you how to create and build your first custom service. So if you already know how to create and build messages, well, creating services will be really simple. So where will we put our custom service? Well, simply in the My Robot Interfaces package that we've already created. Here you have an MSG folder. Let's create SRV folder, and we will put all SRV files inside that folder. And for this example, I will make something quite simple. Let's create a compute rectangle area .srv. Okay, it's important to use .srv and not MSG for services. So this will simply get a request containing the data to compute the rectangle, and it will return the area. So we can go directly here. We have already our message file, and we will go to srv. So what we need for the request is the length and the width of the rectangle. And for that, we will use float 64, which is a primitive data type. Okay, length and float 64 width. Okay, so we have our request. Now we will add 3 dashes, okay, like that, and everything under that will be the response, and the response will simply be the area. Okay, and that's it for the definition. And now to compile, actually to build the source code for this, well, in fact, our package is already set up with everything we need. So in package.xml, make sure you have those 3 lines here that you already set up before. In the cmeclist.txt, make sure you have this find package line and this structure. And now the only thing we need to do is to add a new line, srv compute rectangle area.srv. Okay, so any new interface you will create in MSG or SRV folder, you simply add a new line here. You save the file, and that's it. Now we can build it. Colcon build with my robot interfaces. Okay, and our service is now ready. So here, let's source our bash rc. Okay, and you can find the interface with Ros2 interface. Show my robot. Let's press tab. Okay, let's press tab twice. And you have the different interfaces you have. So SRV, compute rectangle area. And you have the service definition here. So that's it. And now to use it in your code, well, you will simply need to add an include for that message. You will also need to add the dependency for your package. But as you saw in the previous lecture, we already added the dependency when using hardware status. So we already have a dependency for my robot interfaces package. And I will not actually write a code for that service definition because we will practice more on that in the activity at the end of the section. But if you want, you can create your own service server in Python or C++ or both, using this to compute the rectangle area. And then you can call the server from the terminal or even create a client in C++ or Python. In this lecture, I will come back to the Ros2 command line tools you can use with the Ros2 interfaces. And in fact, you've already seen most of them during this course. This will be kind of a global reminder, quick recap, and also I will add a few more tips. So first of all, let's source our bash RC. So we have all the custom interfaces that we have built previously. We are sure they are in this session. So you have the Ros2 interface command line tool. If I press tab twice, you can see we have a few commands. And you already used a lot Ros2 interface show. When you already know the message name, you can my robot interface, for example, with SRV, compute rectangle area. When you already know the name of the interface, well, you can find it like that. Ros2 interface show example interfaces, let's say message string. You can find the data you need to send from there. So here you see we have primitive data types float and string. Okay, what you can do also is to Ros2 interface list, and that will list all available Ros2 interface you have on your environment. And as you can see, that is, well, quite a lot. So that is everything you installed or built by yourself. So you have first messages, and then you can see we have services here. So you can see, for example, let's go here, example interfaces. They are all here. We have here geometry messages. Okay, you saw a little bit of geometry messages, for example, the twist and vector3. We saw that on the GitHub package, but actually they are installed. You also have sensor messages. And if we go to M here, my robot interfaces, hardware status is listed here, and you have the same for services. My robot interfaces is here, and you can see the other services that you have. Okay, and what you can do also is, because this is the complete list to interface package, that will show you every message or every interface with messages and services inside one package. So for example, sensor messages, which is the name of the package, and you have all the interfaces from that package that you can use. And this is exactly what we saw on GitHub. So that are the most useful commands with Ros2 interface. And now let's do a quick recap with what you can do with interfaces and topic first. Let's start Ros2 run my Python package. Let's start a publisher. So okay, we have the hardware publisher, hardware status publisher. So here you can find easily what you need to send on the topic actually directly from the node. If we do Ros2 node list, okay, let's go from the node to the interface. So you have the list of nodes, and you see you have the hardware status publisher. So Ros2 node info with hardware status publisher, and you will see that in the publishers you have hardware status topic, and you also get the name of the interface. So from the node name, you can directly find the topic and the name of the interface. You can also find it by doing Ros2 topic list. You see hardware status, and then Ros2 topic info hardware status, and you find the name of the interface, and then Ros2 interface show with my robot interface message hardware status. And directly from the node name or the topic name, you can find what you need to send or receive. And if we start now a service server to run my package, let's start the add to int server that we already have. Okay, so here we will do the same thing. Ros2 node that we have a new node. So Ros2 node info add to int. On the service servers, we have add to int, the name of the service, and the interface. And you can also find it with Ros2 service list. You see that we have the add to int. You do Ros2 service type. Okay, with Ros2 topic it will be info. Here it's type. Add to int, and you get the name of the interface, and then you simply need to do Ros2 interface show example interfaces, SRV, add to int, and you get the interface. So the Ros2 command line tools for interfaces are quite useful to actually find what you need to send or receive or request, and you can also see all the available options that you get. And again, make sure to make the difference between the topics and interfaces. The topic is the communication layer, and the interface is the communication layer, and the interface is